All right. Hello, everyone. Welcome back to the third episode of Gradient Descent. Um, and today we're going to be talking about Agentic AI. But before that, for new listeners, just wanted to set the stage here. So we're a podcast where we go deep into one specific topic about AI every episode. And this one we're going to be talking about Agentic AI, which we'll define in a second. But yeah, welcome back. And with me, I have my friend and longtime colleague, Alex Thomas.
Hello.
And my name is Vishnu. I'm the founder and CTO of WiseCube, and we do AI stuff, specifically responsible AI and things like that. Anyway, with that out of the way, all right, Alex, we're going to talk about Agentic AI this
Yeah.
week. Let's start with just defining. I know it's a huge buzzword right now in the industry, and I hope we can try to sort of be as less buzzwordy as possible, around this, and try to
Yeah.
get into the meat of the subject and try to separate the wheat from the chaff, as they say. So let's just define what it means for people who haven't heard about it and been living under a rock for the last 3 to 6 months.
Yeah. I think your sort of reference to like buzzwords is very important here because in sort of in our field in software, especially in AI, there's a bit of a habit of people coining new terms for things in order to improve their SEO or to be able to let them trademark something. But really, like agentic AI is where you have some sort of model, which is an AI system that has some either some level of capability with it, whether it's like tool usage, which is sort of one of the terms that's more used now, or perhaps like some sort of like other reference that it knows how to use, which is often lumped under tool usage. And in the paper, they sort of talk about that, about how one of the problems with the research about this sort of like new agentic AI stuff is people are coming up with different terms, and it's very hard then to coordinate research. Because I would say that the problem is almost maybe a little bit worse now because it's not just like slightly different terms that people are using, but it's very different conceptualizations.
Yeah,
In
and
the paper,
I do want to. Sorry, yeah, I do want to point out that what like for people trying to understand like how is this different from chatbots or like any other AI that existed before this. I guess the operative word is like it, at least that people tend to think about is generally like agents tend to actually do stuff, right? Like they
yeah,
tend to take actions, right? As not just be a support bot or just talk to you, which is so far what we've seen some of the bots and AI solutions out there do, which is just, hey, it's a chat bot. You talk to the chat bot, it talks back to you, it can write code, it do stuff. But now we're talking about the next step in the AI
yeah,
evolution and saying having them actually do stuff on behalf of you as the human being, right? So
yeah.
in a way you're trusting the agent to do more on
Yeah,
your behalf, right? So
and like you mentioned, I think, it's more than just chatbots. I mean, you could have an agent that is a chatbot. Like the actions could be it talking to you, but certainly the thing that differentiates it is that if you have just like an LLM that you just give your like user inputs into, and then you just return the model outputs, like that would sort of not really be an agent, or it'd be like like the simplest thing. But if let's say you have a chatbot system that like takes the inputs, maybe does some research, maybe decides depending on like what was input, like how to respond or with what things to respond, like that could be an agentic system and it'd be a chatbot. But it's like these capabilities and. So the paper we're talking about today, that's the cognitive architectures for language agents paper. CoALA.
otherwise known as the koala. Koala is
Yes.
that is it? Yeah, I love that.
Um,
I love that when scientists like come up with like backronyms to make
yes.
their thing sound cool, right?
Um,
Go ahead.
yeah.
Sorry. Yeah, we'll put links to the papers on the show notes. But
Yes.
so we wanted to sort of center this conversation around something more meatier than just talking about a bunch of buzzwords and frameworks. So this is the paper we decided to sort of center around. Um, So before we get into the paper, Alex, a
Yeah.
little bit of history as well. Where, I mean, to your point, this idea of like AI having more agency and being able to do stuff and being able to, think memory and reasoning and planning, it's been around forever, right?
Oh
I
yeah.
mean, it's, planning, in fact, yeah, just talk briefly about that, how we got here, um, and then we can dive into the paper itself right after that.
Yeah, so if we look back towards like some of the oldest ideas of AI, the idea of them having agency to do something was sort of like one of the main ideas. So if you look even at something like on the Voyager probe, there are like a complex system of heuristics that they have on that for it to try and adapt when certain systems aren't working. So, for example, recently they had maybe a couple years ago now. There was like a communication breakdown where one.
So, just when you're saying Voyager probe, this is the Voyager probe that was sent out to Saturn. Is that the probe
Oh,
you're
this is
talking
this
about?
sent out of the solar system.
Okay, out of the solar system. Okay, okay. So this is the NASA probe that was sent
Yeah,
out. Go look at, and so
and
okay, yeah, go ahead.
it had part of its communication system breakdown, and it was actually able to adapt to use another part of the communication system to reestablish contact. Um, uh, so even like before we have sort of like our modern, machine learning, deep learning notions of AI, the studies of artificial intelligence were sort of like always thinking about this idea of agency because we want to the idea is to build these systems that can like react to their environment, um, and that's
And
sort of
then
like
not just React,
yeah,
right? It's also being able to plan and reason
yes,
with some
yes,
level of memory, right? And because yeah, we've had systems that react all the time that are very simplistic, but can they actually start reasoning and planning and with some level of idea of the context and the memory around its environment? And
yeah.
now all of a sudden they start to look like they have more agency, right? So
Yeah, and they talk about that here about how it was one of the concepts I think that they explored was very interesting, which is so let's say you want to build agentic systems, you do have to consider, well, what is the environment and what is the memory, what is the action space, so like what are the set of actions that you can take, and there's like a whole out another dimension of designing these systems that's outside of just the sort of like very machine learning based, oh, let's just tune the model and get to return responses. Now you have to think of like design, like, oh, my system, if it can take these actions, and how do these actions relate to each other, and then how do you use an LLM to do exactly what you're talking about, that sort of planning, that analysis and planning.
okay, so now we're getting into the meat of it. So
Yeah.
now, yeah, so let's dive into the paper, the CoALA framework, um, and let's talk about their central idea in the paper, which is sort of the mind of the agent itself
Mm-hmm.
and a way to define some of the modules and some of the things that a typical agentic AI mind has to do. So walk me through sort of their main ideas that's laid out in the paper.
So yeah, first of all, I want to say, like, I really do like this paper. It's uh like in like preparing for this episode, I ended up like falling through bunches of like rabbit holes reading through it. So it's a really I'd say fun read. Specifically because it's like really dense, and you can like, go read about like production systems, which is like a whole interesting topic. Then like they go over the SOAR framework, which is really like a central inspiration for their ideas here. Um, so um, in their framework, there's there's two ways you want to take it from. There's what are these systems doing, and then what are the parts of them.
Mm-hmm.
So one of the things they talk about, so what we are alluding to, is that there's this observation, planning, execution. It's like classic like agentic modeling.
Mm-hmm.
And within like the planning phase, there's another three steps, which is the proposal, the evaluation, and so there's like proposing a set of possible actions, then evaluating them, and then selecting them. So in the actual agent, we have yes, you have the memory, and they go a
Yes.
lot into talking about like what are the different parts of the memory. Specifically, that one example they bring up, as far as like the issue with chatbots, is that if you have something that is using Wikipedia, if you're using Wikipedia directly, that's an external memory source, so you can't modify it, right? So it's a sort of this external thing. However, if let's say you host a copy of Wikipedia, you could potentially alter that. Because the idea is that you have external memory, which you can't update, you can't alter, and you have internal memory, which as you work on things, you can update. And that memory is not just like document stores; it can also be like past actions you took or past conversations you took.
Yeah. Yeah.
Yeah.
I love this idea of different kinds of memory because it is an idea that's obviously in cognitive science itself, not just right, like actual neural science, right? We're talking
Yes.
about how the brain works. Now, so this is where it gets really interesting to me. Is like when AI starts resembling more and more like how the our actual brain works, and we're starting to get inspired by that. And so, one of the core ideas, as you pointed out, is like these different kinds of memories that these agents are starting to rely on, right? And so and they lay out these different kinds of memories. They, like you said, like there's this semantic memory, which
Mm-hmm.
is, it's all about facts. It's all about like, hey, what is the capital of Colombia or whatever, right?
Yeah.
And so those kinds of facts, which ideally shouldn't change um, that often, but if it changes, once it changes, and it's largely sort of considered as facts, right? And so,
Yeah.
and then there's this idea of episodic memory, which is just the experiences that the agent has in the course of interacting with other agents or humans or anything in between, I guess,
Mm-hmm.
right? And so it starts to collect all these experiences and put them in this episodic memory because why if I am interacting with Alex or with a human and and there's a conversation that went bad and I realize that Alex doesn't like certain things, I want to actually remember that. So when I
Yeah.
talk to Alex next time or I'm doing stuff on behalf of Alex, I am taking that into consideration. Now, would you call that a fact? Maybe, maybe not, but it's definitely one of the experiences that I've learned, right? And this
Yeah.
sort of jives with how we tend to think of things as well, right? Like in our brain. And then finally, there's this third kind of memory, which is the procedural memories, though they talk about, which is like how do I do things, right? Like how do I ride a
Yeah.
bicycle, or how do I do it, the hows of the world? How do I talk to this other agent so I can actually do stuff, right? And to me, this is a fascinating thing because now we're saying, okay, hey, there's this different kinds of memories, and as part of doing things and as part of reasoning and planning and decision making that the agent is going to do in the course of its operations, each of these three kinds of memories will have to be relied on, yes, but also it has to be kept up to date, right?
Mm-hmm.
Because that's sort of the learning phase, right? Like it's not enough if I just give you these memories and then say go. These memories, like all our memories, are
Yeah.
going to be out of date if it's not kept up to date, right? And so that's the other part that we should probably also talk about. But yeah, so this was fascinating to me. And then of course they talk about this whole action space and decision
Mm-hmm.
making modules as well. But maybe you can talk a little bit about those three, the other modules as well in the paper.
Yeah. So we have like this notion of like the different actions it can take. So what's interesting is that towards what you said with the procedural memory, which is where the sort of like the memory will tie into these actions. That's actually why a lot of this research kind of died down as like machine learning type AI, as most people think of it now, sort of took over, is because in the past, figuring out your action space, so your set of possible actions, and like it's not just like like an unorganized set. The idea is that you have these actions, and there's sort of like relationships between them. Like, oh, if I take this action, then there's these other actions I can take. So you sort of have this, graph-like relationship between the actions. It used to be that in order to do that, they would basically have to take a bunch of experts, sit them down, and have them explicitly design these things. And that was, of course, like a very expensive and difficult thing to do. But now, for a lot of these systems, we don't necessarily need that sort of explicit planning for these actions. So you could have now with like LLMs, they can learn how to use a API, and with the proper descriptions, it can correctly associate these different actions together. And I don't know much about Minecraft, but one of the examples I give in the paper is a system that plays Minecraft, and it learns these actions that can then be decomposed into smaller actions. So, like if it's like there's an action like where it's like fighting a zombie, and if you and as part of like decomposing that, if let's say you find you don't have a weapon, it can then fire off an action to create a weapon in order to fight the zombie. So this idea of the LM being able to take over some of this like expert design part of the actions is a very important thing. And that's another thing they talk about here is like in the past, a lot of this design was very much sort of like explicit deterministic system design, where it's like, you have these set of actions and you set up these plans, but now they can do it in a much more probabilistic way. And I want to actually real quick touch on the one thing you said was like, as we're getting like inspired by these biological systems. I think that's sort of inevitable as we get better at working with language. Like language itself is like not just a code, but also a system. And like as we build these models that are better able to work with language, the systems that we'll build that we need to build to take advantage of that will probably look similar to biological systems because like the language evolved in not just a physical environment, also like a biological environment. And so the way you exploit that value is probably going to be similar to the environment the language evolved in.
Yeah, and that's an interesting point because, look, this idea of services interacting with other services or machines talking to other machines has been around for a long. I mean, that's computer networking.
Yeah.
Right. I mean, think about it. Right. It's just it's just the protocols that we define for these different computers to talk to each other. Mm-hmm. They've been around since early computing days for many decades. What is fascinating to me is now the protocol that these computers and machines are interacting with has evolved from like low level things to much higher and higher level protocols to the point where now it is the same protocol that human beings are using, which is, to your point, natural language. Right now, we don't have SOAP protocols or REST protocols. Well, we still do, but that is no longer the way these things communicate with each other. But it's actually natural language, and because of the power of these models like LLMs and whatnot, that becomes the protocol or the interface that these machines are starting to talk to each other. And to your point, that requires that the internal stack to manage this protocol itself starts to resemble what we have to be able to communicate with each other in terms of our sort of biology, which is fascinating to me, right? And so, to me, so this is sort of like, as you pointed out, it's inevitable. But and the other thing, as you pointed out, was like, hey, how is this different than before? Like we used to have that's one thing, which is like the protocol is a much higher level protocol, and two, we don't have to deterministically code up whether it be action planning or decision making, right? We never have to code the agent to saying like, hey, if this happens, do this, and if this happens, do that, and like and a whole sort of if then else conditioning, which is sort of how AI started, right? Like, hey, it's like if you think about all the list based expert systems that were coded up, which really started the whole AI revolution, the first one. It was just a bunch of like if then else logics that obviously was very brittle, as we all know, because you can't code up every single possible condition, and it just breaks down after a while. And that's where the whole LLM's probabilistic loop comes in and makes this much more flexible, right? And so I just want to bring all of this back together. So we've talked about a lot of the things. We talked about the memory and how there's different kinds of memories, and we talked about the action space. And then briefly, let's talk about decision making and planning and whatnot. And then let's bring it all together and saying like, how does how does this all work? And then we talked about the LLM, but like, how is this all sort of come together, and how is this agent going to actually work in a real world scenario? Maybe we can dive into that a little bit.
Yeah, they do give a couple of case studies. I mentioned the what's it called, the Voyager. I guess it's now a second thing called Voyager. That's the Minecraft one. They talk about how React as well as sort of like a very like a simple agent relative to their framework, even though it's like very expressive and people use it broadly now. I think one good thing that helps with the conceptualization is tree of thought, which they talk about in the paper a great deal. Because with chain of thought, right? You have sort of like whatever like your system's input is. Then you have a series of reasoning steps that your agent will go through. It's like, okay, I guess input, like what is this thing? What should I say to this thing? Like that. With tree of thought, it's more of like, you get an input and you generate a sequence of steps that you take, decide which one of those steps, and then take that, and then decide, and the next sequence of steps. And
so this is the core loop now. No, this is the core agentic loop that we're talking about. This is this to me is interesting because this gets to the heart of the matter. Well, like, how do you code up a new agent, right? Like, what does it do? And like, game developers or just gamers might know there's always a core game loop, right? That's like, hey, listen for input, like when something happens, and then react to that, update your environment, and then like you keep doing that in a loop, right? And similar to that sort of game loop, there is an agentic loop, if you will. And talk to me about that sort of core agentic loop. What is happening? What is the agent actually doing? What are the steps it goes through? And then how does some of the things we talked about earlier, like the memories and all these other things, how do they fit into this loop?
Yeah, so if we go back, we go back to like this sort of this step in this loop of observation, planning, execution, right? So the idea is in this loop is that the observation can actually be multiple things. It can be a user input, but it can also be sort of digesting experiences. We talk about like, oh, you have this interaction with a user. They talk about one of the ways of like let's say updating various parts of your memory of your system can be like, okay, well, you've just finished an interaction with a user. Now you can just like take that whole interaction and you can have a process where it will evaluate that interaction. It's like, oh, this was a positive interaction. This was a negative interaction. Or various other associations you might make with it, not just sentiment. And it can then use that to like update its actions in the future. So
wait, Alex, but let's back up. But what is the core parts of the agentic loop? You said observation, planning, and then execution, right?
Yes.
And observation is the first step where the agent is getting an external input, or it's actually observing something, and then it goes into planning mode, right? That's the second, and that's the core of what the agent does and how it's different than just a program, right? That's coded out, right? And now you're talking about, okay, when the planning mode is when it says, hey, I want to come up with a different set of options to how I want to react to this, or what, and then I want to evaluate these different options, and this is the chain of tree. Is it chain of tree? Is that what you said, right?
Chain of thought.
And then chain of thought, and then tree of thought, right? Sorry.
Tree of thought. Sorry.
The tree of thought, and then I want to select one of these options because I have some way of evaluating which of these options are the best, given what I know from memory. Right.
Yes.
This is where the memory starts to come in, which is like, hey, given that I know Alex hates DC, I am not going to talk to, I'm not going to talk to him about Batman. I'm gonna stick to Marvel characters. I'm gonna stick to like everything when I'm actually making analogies to talk to him. This is something that I have to use from my semantic memory, or maybe my experience memory, right? My episodic memory when I've actually had conversations with Alex before, and he sort of reacted negatively about when I did this. And so I'm going to sort of maybe get him a T-shirt with with Daredevil, on it. And I'm just.
And so like, I think that what's good is like there's a lot of examples here of what are the actions. So the actions, like there's like a robot walking. That's a set of actions, and you can have the same loop in that where like it gets like sensor data, it then has this planning phase where it says, okay, well, given this sensor data, what's the commands I should give to the actuators to move the parts of the robot. This loop could also then be applied to like what we're talking here with a chatbot. Like, oh, you have these interactions with the user. So the user gives input. You access episodic memory from previous interactions within the conversation or even before, from semantic memory of what other things are relevant. So if you get the input, that's the observation. You access different memory, and that's going to be the things you use for the planning. And then the action is going to be responding to the user. But also, I brought up this other example where it's very similar to that. It can be like a post-processing of a conversation where the action can actually be updating memory. So you can
This is just to be clear, this is after the fact. Okay, so now I've had the interaction, I've had the observation, I've done the planning, I've maybe selected the right action to take, and I have executed on that action because now I know, and then I know how to actually execute the action. And it might be like, hey, sending an email or buying something or what have you, whatever the action was. And I've done that, but then I want to record the memory of what I did and how my action ended up. Was it good or is it bad? Any feedback that I have about it. And I want to then go and update my memories, right?
Yeah.
I want to update my semantic memory. I want to update my episodic memory, my procedural memory, or my working memory, and all of these different memories that I have, so I can learn as just like a human would learn. And I want to keep track of this because for the next time, I want to be able to use this. It's right. That's the idea, right? So,
and there's examples of using these types of things to update memory for any of the types of memory. So you would try semantic stuff to say static. Well, it sort of depends on what the semantic memory is. You actually let's say you have some sort of personal shopper recommendation system, right? That you chat with, and it'll recommend clothes to you. If let's say I'm chatting with it and I mentioned that I much prefer Marvel to DC, it can record that as semantic memory about me. If it recommends something that's that I very much don't like, it can actually that of course interaction will be recorded as episodic memory, and it could say in this conversation this stuff happened and it left with wasn't a good interaction. Similarly with procedural memory, they actually bring this up in the paper. The potential of being able to update prompts. So let's say you have something with you're doing code, and so it generates code, and the person keeps on correcting something that it's generating. It can then potentially say, oh, okay, I'm generating this code incorrectly because the user's constantly correcting it. So it pulls that stuff from episodic memory and can try and update the procedural memory, that is the prompts or even perhaps a set of heuristics around generating the code in order to update that.
It's very much similar to how we do things, right? There's always, we have different kinds of memories, like the short-term memory, long-term memory, and as we all know, there is a process that's built into our brains, and where we do move stuff from short-term memory, long-term memory, and people say hey, it usually was we're sleeping or different cycles of sleep where this actually happens, and that is not unlike what you're talking about here, which is hey, something can be recorded in episodic memory, but there might be a process that says, hey, I'm going to just look at all the things that happen in episodic memory. I'm going to decide if I want to move some of that to long-term or semantic memory as a fact, right? Mm-hmm. And that process might be just an offline process that's always constantly sort of running and saying, hey, what needs to happen here? How do I update my memory? How do I move things between memories, or maybe even purge parts of my memory because it's been so long? By the way, this is something that we don't, humans, right? Forgetting is actually a feature, right? Yes. We don't realize this because you don't want your memory to constantly keep growing. And because for two reasons. One, it's probably not efficient, but also a lot of the things that we learn are probably not relevant to just keep around forever because things change all the time, right? Yeah. And so what was true then may not be true now, and so you want to constantly keep your memory updated, and by removing and purging things that are no longer relevant or are factually accurate, right? So,
or even just partially, because if you consider very sort of basic concepts of memory, if let's say you're a caveman and you go down this one path that branches down a river, and there's a whole big wolf pack there. Like that may not. I mean, like it's maybe good to remember that. But if let's say your tribe moves on, you don't need to remember that particular branch of the river that you no longer live near has wolves. But what you do want to remember is like what was the signs that there were wolves there. So like you want to digest these memories, and I think that like that's a very useful thing here.
Right.
And I think
Yeah. Go ahead.
I think another like very usable thing that they bring up here, sort of like to bring us like we're these are really cool conceptual things that can help people design much more sophisticated agents. But there's another much more tangible thing, which is like this sort of organization of like what are the parts, what are the steps that your agentic system is doing, can actually help you organize your code. Like I know we're sort of like going from like the stratosphere down to the ground, but like this is really a very useful way of like organizing the folders in your Python module.
Absolutely. I think this is why I love this paper so much, is because everyone, when they talk about agents, they talk, here's the frameworks and blah, blah, blah. But this is a very sort of almost conceptual, theoretical underpinning and a framework to think about how agents work and how memory works and how these things interact with and how things move. So this is why I like this paper so much. And by the way, to some of the frameworks out there, and I should give a shout out to some of them, they are learning, they are taking cues from this paper as well. And these ideas, LangGraph being one of them, they even have a LangMem, which actually tries to mimic some of the things we talked about, right? In terms of the episodic memory and semantic memory and working, all these different kinds of memories. So yes, so the industry is trying to adapt as much as possible some of these concepts that we're talking about, and so it's not just hey, they're just going off in a tangent. But I wanna bring this back and say, okay, what is next? Okay, what does this mean for agentic AI? What can we expect next? How does this tie into some of the bigger things, like people are talking about around AGI and artificial general intelligence, and are we stepping into that world? Like, what's going to happen? At least in the paper, and let's just talk about that briefly.
So I would say look, first like as far as with AGI, I think that this is I'm going to give sort of like in my humble opinion, we think we're a lot closer to AGI than we actually are. I think we underestimate what human intelligence is. Like the absolute vast array of human faculty is like it's actually, as much as like our ability to comprehend things is so broad, we actually have, I think, a hard time comprehending of what we are capable of. So I do think that we're kind of far away from like human level AGI. I think we might be getting near having a AGI in the sense of a software program that can work across domains, or have like a bunch of skills that's easily extensible. I think that's what we're going towards. I don't think I don't think this stuff is necessarily near the human levels.
Right.
But I think as far as
but there are things that even the agentic AI model can and seems like is going after, right? Like we're seeing things like deep research and obviously speech therapy, like the speech therapists and like collaborators and personal assistants, of course. There's a whole bunch of jobs that humans used to do.
Yes.
And we thought that it takes a lot of intelligence to do, a lot of education and training to do, has now people are starting to question, saying, oh, with this whole agentic AI model, maybe, it won't be as good as what like a human could do, but like it's definitely getting to that point where, it's comparable on some levels, right?
Yeah. And I think that there's also like human augmentation. Like, so we talk about these memories and stuff like that. There's the potential for, be able to use some of these tools to like augment your own memory and your own learning from a thing. So like, people were talking about this like with the HoloLens from Microsoft and all that. But like, imagine never having to worry about forgetting someone's name that you met, because like, when you meet them, if you forget their name, like, like a little thing will pop up and show you their name. Or if you're like writing in your emails, you can have something that can like understand like, what's like the previous context you have with this person. Now, a lot of the recommendations are sort of like, what's like a good email for this? They're sort of like they're not very personalized, but like as we develop these ways for the AI to learn and adapt to a broader set of inputs, you'll get more personalized AI. And I
Right.
think like one of the things coming up,
Is that the future then? Are all of us going to be walking around with our own personal agentic AI that knows everything about us and it's always constantly in our ear? It's like having our own personal angel, like just, we're just walking around with. Is that the future
I
that
think
we're
so
going to
for
live
two
in?
reasons. One is that allows you to like, so from a consumer point of view, that will allow you to like maximize the value you're getting from adopting these systems. Because if you adopt a system that personalizes to you, you get more value from it. But I think there's another thing that moves towards it, which is the amount of data that generates for the use by these companies that are making it is humongous. Like if you have these sort of systems that are learning and adapting to you and like better serving you, them being able to collect data on that is going to be incredibly valuable. So I think it's sort of like personalization because right now we're talking about like peak data, right? Like they've learned everything, so it's hard to get more. Well, if everyone has like their own like their own personalized agent or fleet of agents, the amount of data then that they can collect on you and train new things is going to be humongous.
Yeah, and it's personalized to me, and it's not going to be on the internet always because my
Yeah,
personal interactions are mine, right?
yeah,
I don't put everything on the internet, and so, and by the way, that raises other questions like, well, hey,
yeah,
then if I have more resources at my disposal, then I can collect even more data and train it even more, and it's going to be even smarter, at least about what I care about, and so it's like these it's almost like it's these sort of characters that people build out in Magic the Gathering or whatever, and like they have these personal decks, and like they're going to have these superpowered agents, and so now you can you can sort of differentiate based on how much resources you're willing to build your own personal
yeah.
agent, and that's a whole thing. But maybe that's for a different episode.
Yeah,
Um,
it actually reminds me of Caprica, the spinoff from Battlestar Galactica.
oh yeah, yeah. Anyway,
And it
but
raises these security and ethics concerns of like, what does advertising look like in this world? Like, if you have
yes,
access
yeah,
to like,
yes.
are they going to bias things necessarily? Maybe not like for your interest, but like the sponsored stuff they're going to want to pull you for.
Yeah, this is like a Black Mirror episode, right? It's
Yes.
like, but I think with that, I think just want to quickly wrap up. We covered a lot of ground. Obviously,
Yeah.
this is a hugely vast pace and a very fast moving space right now. But I think for people looking to saying, hey, where can I learn more about this? Definitely recommend the CoALA framework paper. We'll put that in the show notes. Definitely look at LangGraph. They're doing some really cool work as a framework to get started with. But I think yeah. Any last thoughts in terms of this topic itself, Alex, that you wanna?
Yeah. I mean, towards what you were saying, I think like the best way to like take this stuff in now. There's also cool stuff to like talk about in the future, but I think from this, like, take it as a way to like organize how you design your agents. Consider like that loop that we were talking about. Like, okay, so you're building these interactive systems. Think how you can like design and architect your system to support this loop. Um, uh, yeah, um, uh, and I would say that one of the things they sort of bring up here is like a lot of the a lot of things right now are kind of poor in the actions they can take. Maybe that's a way you could look at how to expand your system. Like one sort of the things I asked is like, so in response to like safe AI, if we're using now agentic systems to actually like check for how these other systems are working, like what are the actions that something could take for like hallucination detection or for
Yeah,
like other sort of
yeah.
problems?
I feel like yeah, you're now yes maybe teeing up the our future episode, but yeah, to me we didn't talk
Yeah,
about guardrails at all and
yeah,
responsible AI and how all of this fits in because now you're getting the territory where like not just chatbots and talking to agents or talking to AI, but now you're having AI do stuff on behalf of you, and that is always scary now. Like, how do I know it's not going to do the wrong thing, or it's going to do something that's it's going to affect me economically or personally somehow? And now we get into all of those. Like, what are the things that could go wrong scenario, and how do we put guardrails to sort of prevent those from happening? I think that would be an excellent future episode talk. But like, I would love to hear from our listeners as well to see, hey, what are some of the other topics around this space that you guys want to hear from? But I think with that, I would love to sort of sign off and thank you for listening. If you've been listening so far, there's one guy. Anyway, we'll see you hopefully next time. And yeah, and from me and Alex here at Gradient Descent. Thanks a lot, guys.